Thanks, y'all.
Thank you. You know what they say about Vegas, Sam?
What's that?
What GroupsBy in Vegas stays in Vegas.
Do they say that?
We'll
I've
say
never
that
heard
this
that
talk.
before.
We're gonna take
I don't think
Vegas
anybody
by storm.
actually says that. So we're here basically celebrating RxJS. And RxJS gives us the ability to build really complicated UIs in a really elegant way. And usually what we're talking about when we talk about complex user interfaces is that they're highly interactive UIs. Usually that involves a lot of clicking, a lot of asynchronous activity, a lot of state management stuff, and it can be kind of challenging. So the best example of this is actually the Twitter heart. You go find your favorite dog tweet on Twitter and you can heart and unheart it to your heart's content. And you can notice that the state of the button matches the clicks. And in fact, if we have two tweets and we can find our two favorite dog tweets and go back and forth between them, you notice that they don't ever get mixed up. The one on the top maintains its own state and the one on the bottom maintains its own state. So we want to make something similar. Me and Mike, we're going to make this movie picker application where we have each of us has one of our favorite movies. We'll leave it to you to guess which is which. And we want to implement that same behavior with these emoji buttons. But it turns out that's actually more complicated than it seems, right?
Yeah, it might seem obvious how we go about building this, but it turns out it's not going to be that simple. There's going to be a lot of pitfalls along the way. But first, before we get into how we build this, he's already introduced me, but my name is Mike Ryan. You can follow me on Twitter, GitHub, and Medium at MikeRyanDev. I'm a software architect at an IoT company called Synapse. I'm a Google developer expert in Angular web technologies, and I'm also one of the core team members for NGRX, building reactive libraries for Angular.
One of the founding members.
That's right.
And I'm Sam Julien. I am on Twitter as Sam Julien, very creative and original. I do developer relations at Auth0. It's an identity and identity management company. So if you ever have any questions about authentication, you can come talk to me or any of my coworkers. I am also an Angular and web technologies Google developer expert, and I'm also in the Angular Collaborators program. And I created the course upgradingangularjs.com.
So before we get into this, we want to give you a big warning that the topic we're going to get into is pretty advanced. And it'd be a mistake to kind of go away from this talk and start using the GroupBy operator everywhere in your application. We don't want this deep dive to go like this for you today. Instead, we hope this deep dive is more like this, where you're a Scrooge McDuck swimming in a sea of gold, finding lots of RxJS nuggets along the way.
Yeah, and you don't need to worry about furiously taking any notes or anything. We've got all of the slides and all the sample code at the end for you, and you can always come ask us questions. So going back to our Twitter UI, we have our two dog tweets here, and we really want to do the same behavior in our movie picker application. But we need to make sure that we account for things like slow internet connections or delays with the server or things like that. And so it turns out that's actually a little complicated. So first of all, how do you think we should architect this application, Mike?
Well, I'm an NGRX guy, so I'm going to advocate that at a high level, we're going to do something with the dispatcher and effect pattern. We're going to do some plain JavaScript for this example, but the idea of this here is that we've got our UI components. And as the users interact with them, we're going to map the events that are coming from those interactions into actions. We're going to dispatch these actions to a common dispatcher. For this application, it's just going to be a simple subject. From there, effects that are disconnected from the UI can process these actions to reach out to an API and deliver the results back to our UI. Now, this might seem familiar to you because this idea is pretty popular in the Rx world with libraries like Redux Observable, if you're using it with Redux, or NGRX if you're using it with Angular. So how are we going to actually implement this without these libraries?
Yeah, so we're not going to use any frameworks or any state management libraries. So first we're going to have our dispatcher, and it's just going to be a subject with the type of movie. And then we got to capture those clicks somehow from the buttons. So we're going to first create an observable from the button clicks. And then on each of those clicks, we're going to dispatch an action, which basically just has the movie ID. So the tricky part is, how do we map the button clicks to the endpoint calls? We think we have some idea how to do this. We're going to first use our dispatcher as an observable. And then we're going to use something called optimistic UI updating, which is just basically a fancy way of saying we're going to set the emoji before we update it on the back end. The tricky part is here. What do we do here in order to call our toggle status endpoint?
Yeah, so this is probably where we start to reach for one of our mapping operators, like merge map, concat map, or switch map. But to pick the right operator, we have to understand the behavior of these operators so we get the right behavior of this function call. So when we talk about mapping operators, Sam and I like to sort of use a sorting packages analogy. So imagine you work at some kind of like package fulfillment warehouse and you've got packages coming down a line and you need to take them off and process them somehow. So you've got these packages coming down, you need to process them. What would it look like if we were to use one of these mapping operators to process these packages?
So first, let's look at merge map. Merge map seems fairly simple. So with merge map, if we look at our packages analogy, basically all of the packages would just race down the end to the fulfillment part, and there'd be no particular order to them, which, I mean, that seems okay, right? So let's do this in our code. We're going to use merge map here to call our toggle status endpoint when the button's clicked. And at first, it seems like this is working, right? So we click the button, the UI changes, and then the console output is the database state. And it looks like it's okay. But what about if there are network delays or delays from the server? What happens if we just like mash down on these buttons? So if Mike just like mashes down on Patterson because he loves that movie so much, you can see that we actually have a problem because the UI state doesn't match the database state. So that's something called race conditions. When you're dealing with asynchronous calls, it's actually important that the order is preserved. So I don't think merge map is the right answer here.
No, but you said the words order preserved, so that to me indicates that maybe concat map is the right operator to use here. So if we go back to our shipping packages, we've got our packages on our line. They come in, and they come in a single order. We process one at a time, and then we move on to the next package until all the packages have been processed. So that seems to sort of get us that order that we're looking for. So we'll use concat map in our code, and then we run the application. We hit like or dislike on our favorite movie starring a dark-haired lead, and it seems to be working okay so far. The state we've saved to the backend is matching the emoji buttons. But there's another problem with this operator in this application, and that's back pressure. So there'll be a talk tomorrow from Jay Phillips on back pressure, so I'm not going to go into too much detail about it. But the idea here is that I've got so many requests to fill that maybe my UI starts to degrade in performance because of it. So if I go back to my application and I hit one of these buttons a lot of times, you'll start to see that it's taking me more and more time to process these requests. Now I'm racing the user. If they close the tab or leave the page, there's the chance that the state that I saved to the backend doesn't actually match what they left the button in. So I don't think concat map is the right operator here either, because we really just got a lot of these requests coming out that we don't need.
Right. So it'd be helpful if there was a way we could cancel some of those requests like Kapehe was just talking about. So when I think of cancel, I think of switch map. So let's look at switch map. So if we go back to our packages analogy, in this analogy, basically our packages come to life. One of them races to the front and knocks the other package off of the table, and then the other two get processed.
Thanks, UPS.
Yeah, geez. This is why my dad worked for FedEx and not UPS. So switch map seems promising. Ha, no pun intended. So let's use switch map. Yeah, let's use switch map instead. So if I put it in our code, now you see when we click the button a couple of times, the backend only gets updated once. So that seems right. But what if we were to click those buttons really close together at the same time? Well, there's actually a problem. You can see that when we click both buttons, only one of them gets processed. And at first, that seems really bizarre. Like, why would that happen? But if we go back to how we architected this application, it actually kind of makes sense. If we go back and look at our code, we're using this dispatcher pattern. So we're actually switch mapping on all of the actions. We're not distinguishing between the movies. So if only there was a way that we could, I don't know, maybe group the movies by some sort of parameter, it seems like that would be really useful, don't you think?
Yeah, that would be really handy if there's maybe a GroupBy operator in RxJS. So if we go back to our shipping packages analogy here, what GroupBy is going to allow us to do is it's going to allow us to sort through the packages based on some kind of criteria. So here I'm taking the packages and I'm filtering them based on their color. So now I've got an independent stream or lane for these packages to go down based on that criteria. and then I can apply the concat map operator to them. But we don't want to use concat map, right? We want to use switch map to get that cancellation. So if we use switch map instead, we'll filter them out based on their color, and then I can apply that cancellation behavior of switch map to these independent streams, allowing me to not have movies sort of race each other when the user is interacting with this UI. So I go plug it into the code, and I start interacting with the app, and the cancellation is still working correctly. If I interact with just one movie at a time, I'm only saving the last request that I need to the backend. That all seems to work great. But now what happens if I do both at once? So now if I'm racing between, you can see that I'm getting the right network requests per movie. As I hit the button for the movie, it's not canceling out any pending requests from the other one. So how do we actually do this in code?
I think that's the end of the talk. You don't need to see it. All right. So in order to talk about how we do this in the code, let's take a quick step back and do a quick review of higher order observables, because that's a big, scary sounding phrase. So let's use arrays as an analogy. Let's say we have an array of fruit, and then we decide to have an array of arrays of fruit. So we have 3 arrays of fruit that are all nested inside another array. I could call the flat method on the array prototype and smush down all of these arrays and end up with one single array. And I'm using smush to shout out to Ben. And then we could use the same thing with observables. So let's say we have an observable of these fruits, and then we have a nested observable. So we have 3 observables of fruits inside of another observable of fruits. We could use one of our combination operators like merge all and smush everything down into one observable of fruit. So that seems fairly straightforward. And it turns out that a lot of these combination operators that we've come to know and love and maybe fear are just syntactic sugar. So merge map, for example, is just map combined with merge all. And we'll come back to that later. So now I think we can talk about GroupBy and how to use it.
Yeah, GroupBy, the best operator ever, no foot guns at all, right, Sam?
Nope, you can all just run right out and use this right now.
So let's plug it into the code, and let's start using GroupBy in a simple example. So here I've got some packages, and I'm going to group them based on their color. This is going to produce a higher order observable, where the 2 inner observables are just of the packages that share a color. If I want to then flatten it back out, I can use the merge all operator afterwards to create a simpler flat observable. And that's sort of what's going to be kind of interesting about this operator, is first I create a higher order observable, and then I'm going to flatten it back out after I've done some work. So let's take our action stream, and let's start grouping our actions based on the movie ID. So now we have a higher order observable, where each inner observable is one for each movie in the UI. I need to flatten it out, but before I flatten it out, I can do some work on each of those individual observables. So here I'm going to use the map operator, and I'm going to take those grouped observables, those inner observables, and I'm going to apply some work to them. So from the top, first, I'm using the GroupBy operator to filter these down based on the movie ID. So I've got a higher order observable where each inner observable matches to one movie on the UI. Then I'm going to use the map operator to map this inner observable into a new inner observable. And to do that, I'm going to apply the switch map operator here. So now I'm applying that switch map operator per movie rather than for all the movies like I was doing before. And then at the end, I need to flatten it back out, so I'm going to call merge all. So plugging this into my code and running the example, you can see here that things seem to be working correctly still. I can mash the button a bunch of times. I'm only getting the last request. If I bounce back and forth between 2 movies, I'm only canceling per movie. No race conditions so far. But there's kind of an underlying problem here.
Yes, we have a hidden problem that isn't obvious at first. So if we go back to our packages analogy, and let's say we want to sort these by color using GroupBy, what's going to happen is that first, there's going to be a blush group. That's the official name of this color. We're going to use official Pantone names for these colors. So first there's a blush group that gets created and just sits there. Then there's a fountain blue group. Then there's a soft purple group. Then there's a light sky blue group. And then there's Tony's pink. And these groups just get created, and they just sit there, and it just keeps going on and on and on and on. This last one's called Mindaro. I don't know why. But they just sit there, and they never go away. And so what we've done is we've actually built a very efficient memory leak. So good for us. But it turns out there's actually a way we can fix this. If we go look at the signature of GroupBy, there's 3 parameters. There's the key selector, which is the thing that we are grouping things by. There's another one called the element selector. We're not going to get too much into that, but it's kind of like a shortcut for map, where we could do some sort of transformation. But there's this third one called the duration selector that we want to look at. The duration selector returns an observable that will actually clean up those groups when they notify or complete. So that sounds pretty good. So we're going to look at the group's duration selector. So we've got our group by. We're going to use the key selector for the movie ID. We're going to keep the element selector the same. And now we have our duration selector. And what we want to do is we'd like to discard these groups after 15 seconds of silence. So if something emits and then 15 seconds go by, we want to clean up the group. And we're using 15 seconds here because that's the max timeout of our HTTP requests. So the question is, how do we actually build this? What kind of RxJS wizardry do we need to get this 15 seconds of silence?
Well, first, we're going to want to take a look at the timeout with operator. Now, this operator takes 2 parameters. The first is time in milliseconds, and the second is an observable to switch to. And the behavior of this is that it's going to listen to an observable, and if that amount of time goes by where it doesn't hear anything, it's going to unsubscribe from it, and it's going to switch to the observable that I passed into the second parameter. So if I apply it to a line of packages, let's say I get a package, and then 15 seconds go by, I can switch to a different observable. Here I'm going to switch to the empty observable. It's built into RxJS, and it's basically an observable that just completes. Doesn't emit anything, it just ends. So now I've ended up with a package observable where I get my first one, 15 seconds goes by, and it just completes. But that's still not going to quite get us where we want to.
No. So if we go back and look at our duration selector definition, there's a caveat here that it's going to clean up the group when it either notifies or completes. So when we have our timeout with here with our 15 seconds, the emission of the, I think this was called blush, is the blush is actually the notification. So what's going to happen is the groups are just going to immediately go away. So if we look at our demo and only use timeout with, you can see that when we click the button a bunch of times, we still have the race condition. Like GroupBy effectively just disappeared. So what happened here is that we've actually just rebuilt merge map. We just sort of like started back from the beginning, and nothing is what we want. So, okay, how do we get rid of the notification so we only clean up the groups when they're silent for 15 seconds?
Well, thankfully there's an op for that. So
he stole my joke. That was my joke.
I did. That's what happens when you get out of order here, is I get to take your jokes. So here we can use the ignore elements operator. And effectively what this does is it's going to take all those notifications from a source observable and ignore them. So if we have a line of packages, it's going to produce an observable that takes the same amount of time as the source observable, but has no more packages on it, and then it just completes. So what we can do is we can pair this up with timeout with to create an observable that's going to time out after 15 seconds of inactivity, but is going to be otherwise empty. So again, that timeout with, we're saying 15 seconds, which is the max time of our HTTP requests. If I stop hearing for new things after 15 seconds, switch to an empty observable. And for all those things that did get emitted before I timed out, I'm going to ignore them using the ignore elements operator. So if I apply them to my line of packages, I've got my blush package coming in, then 15 seconds goes by, we unsubscribe from it thanks to timeout with, we switch to the empty observable, which causes us to complete, and then we call ignore elements that gets rid of that blush package. So using this, we can plug it in to our GroupBy operator to create that duration selector. So that first parameter, that's our key selector. This is informing the GroupBy operator that we want to group items based on the movie ID. The second parameter, that's our projector or our element selector. This would allow us to map to something else. Here we're just going to map to the action. We're not going to do any kind of transformation. And then that third parameter, we're going to build up an observable using those inner observables, those action groups. And we're going to apply the timeout with and ignore elements operators to that to create an observable that will cause the GroupBy operator to discard those groups if the groups are quiet for 15 seconds. So with that in place, I think we've eliminated the highly efficient memory leak we had before.
Yes. Okay, so let's go back to our code. And what we want to do is with this switch map, we're going to insert all of our GroupBy stuff, and it transforms into this big mess of code. So let's just like take it one step at a time here. Let's zoom in on GroupBy. So GroupBy, again, we're grouping by, back up. Okay, we've grouped by our movies by ID, and then we're cleaning up our groups after 15 seconds and not having any memory leaks. Then we scroll down to the map operator, and here's where we're taking each of those groups and calling our toggle status endpoint. And then at the end, since we've got all these nested observables, these higher order observables, we're just gonna merge everything down into one observable, flatten everything down. So it looks like this. And for the sake of repetition, let's just like go through this one more time. So if we go back, the whole block here is grouping everything by the movie ID. And then this whole block is saving that status to the endpoint on the back end. And then the end is just flattening everything back down. And it turns out there's one more way that we can make this a little bit better. We talked about this earlier on, but map and merge all can actually be combined to become just merge map, which makes this a little bit easier to follow. Well, I guess it depends on how you look at it. Maybe it's not easier to follow. But yeah.
So let's plug this into our demo. And now, again, we've got that same behavior we've been striving for. You can hit one of these buttons multiple times. The UI is updating optimistically, and we're only making network requests to the backend that we have to make. The final result that we save in the backend matches our optimistic UI. We can go back and forth between these two movies, and they're no longer interacting with each other. That cancellation behavior is now isolated to each independent movie stream. And what we've really done here is, at the top, going back to that dispatcher architecture, is we've sort of said that, okay, if we're taking all of these events and mapping them into actions and dispatching them to a single unified stream of all those actions, we've had this potential performance bottleneck here at this point when we're mapping actions that are coming from that dispatcher into some kind of side effect. And using GroupBy, we've managed to take that unified observable, we've managed to split it up into smaller independent streams that we can apply these cancellation behaviors to safely. Now we no longer have to worry about things like back pressure or potentially race conditions, and we no longer have any efficient memory leaks built into our code. But it was a lot of code, Sam. Is there any way we could have maybe consolidated this down?
There is. We've only got a few minutes left, so it's probably for the best not to get into it. But we actually could extract that whole long thing of code and put it into a custom operator where we might call it maybe switch map by key and just pass in the key that we want and the function that we want to use and not have to worry about all that code every single time we want to use it. Now, thankfully, even though we can't get into that now, we've actually got your back. If you go to samj.im/rxjslive, we've got, well, in a few minutes, we'll have all these slides up there. But we also have the whole movie picker application sample code is up there. And the way we've broken this down is we have a branch for each of the combination operators. So one for switch map, one for merge map, and one for concat map. Then we also have a branch demonstrating all the GroupBy stuff, so you can look at all that. And then we also have a branch demonstrating extracting that into a custom operator called switch by key, I think I called it. So this is a lot of stuff to wrap your head around. So feel free to dig through the code and come talk to us anytime. That's why we're here. I love these smaller conferences because you can actually like get to know people and hang out and things like that. And I think that's basically it. I mean, easy peasy, right? No big deal. Just like do all this stuff and you'll be fine. It's fine. Everything's fine. So thank you very much.
Thank you.